Hi guys, welcome back. In this video, we're gonna get all of our information in this table by using in-table calculations, and we're gonna use that information to visualize the information that we have. The first thing that I need is a position, and the reason why I don't type in the position here every time is because it doesn't change, and that's the purpose of the profile. Everything in here does not change. The sex will not change. I guess it could, but for our purpose it won't. The date of birth won't change, the position won't change, and for our purposes, the group or the team that they're on does not change for our data purposes. Although, let's say that you want to aggregate the information based on when a person was in a given group, then you may want to enter that into your table and not have it as part of the profile. So to get the position, we're going to use a formula called index match. And I'm going to do equals index, open parenthesis. Now it's saying, what do I want to get the index of? I'm going to go to my profile table, click on the first cell, and notice when I do that, it says table profile at position. I don't want that at sign there. And the way that you do that is I'm going to scroll down to the bottom, hold down shift, and click the last item in my table, and notice the at sign goes away. And now, so I want to get the position, comma, but I need to match it on something. So I'm going to match, open parenthesis. It's asking for a lookup value and saying, what do you want to match it on? Well, for the lookup array, I know that I want to match it to the player name here, but I want to match it on the player name here, and that's where the at sign is meaningful, and we need that. Comma. So I'm matching the player name to the player name in our array here, or in our table here. I'm going to select them all and do comma, and now it's asking me for a match type. I want it to be an exact match, 0. Now I'm going to close the parenthesis and close the other one, close off the formula, and click enter. Now I'll have a position for every player automatically pull in for every testing event. And what I'm going to do now, this is a habit that I have, is I'm going to say if there's an error with this formula, then let's make it blank. So before the index occurs up here, say if error, open parenthesis, if there's an error with anything going on in here, comma, let's make this blank, which is 2 quotes. Close the parenthesis, click enter. So now that we have this formula all set up, what we can do is we can copy it and paste it to the group. Everything remains the same, except we're changing the position to the group that we want. So in the table profile, or in our profile table, instead of position, I want the group. And it should pop up for you if you're on a PC. If you're not, you can type in the word group. And if I click enter, now I have the group for each player as well. What I'm going to do is with this table, number one, I'm just going to reformat it right now because I don't want the blue there. I like gray. So I'm going to go table, design, and I'm going to format it in a different way. You don't have to do this, but I'm going to format it, I don't know, like this. And now what I'm going to do is in the columns that are calculations, so that I know that they're calculations, I'm going to go home and I'm going to color them a certain color. Maybe I color them, I don't know, red. So now I know these are calculations and I won't overwrite them. Now, we need body fat percent. And we're going to use, at least you may have a certain formula that you use, or you may not even care about the skin folds. And this is the case, same thing with CMJ trials. I like having the trials of each thing, and I like having the skin folds in my database in case I need them. So you should never sacrifice your data for ease of input, if you will, if you think that you're going to need it. So I don't know if I want the best or the average counter movement jump. So If I were to just type in the best number in one column, and then I say, oh, you know what, maybe the average would be more appropriate, my data is gone and I don't have access to it, or I'd have to go back and it'd be a mess. So the body fat percent calculation that we're going to use is the UHAS formula, which is used at the NHL Combine when they do skin fold testing, and it requires 6 sites, which is chest, tricep, suprailiac, subscapularis, abdomen, and thigh. So I'm going to type in that formula now. But because I know that the skin fold calculation uses a sum of these skin folds, it might be easier for me to enter it in or collect a sum of skin folds also and use it in this equation. I'm going to do it that way, but you don't have to. So I'm going to click on column O, and I'm going to right click and go insert, and that'll insert another column into my table. I'm going to call it sum, or I'm just going to call it skin folds sum. And there are a couple ways to do this. I'm going to do it this way, where I just go equals sum, open parenthesis, and now it's asking me the numbers that I want to sum. I'm going to click on I and drag it all the way here, because I want the sum of all these skin folds. I'm going to close the parenthesis and click enter. Now this is all of these skin folds added together. Now to calculate body fat percent, I'm going to do this, but there's a difference between genders or sexes with body fat percent calculations. The NHL Combine uses a calculation that is not, they don't have an equation for females because there are no females at the NHL Combine, at least today. So what we might have to do here is pull in the gender also. So why don't we do that? Because we know exactly how to do that. We just did it here. I'm going to add in another column. Clicked on column G, right click, and insert. The color stays what it was before, so I don't have to color it, even though this will be a calculation. I'm going to say sex. And I'm going to do exactly what we did last time, where I click on the formula next to it, because it's pretty much the same thing. I'm going to copy it, paste it in here, but now instead of pulling through the group in the profile, I want sex. If I click enter, now we have a sex for every participant. And you may not have a cohort of mixed sex, so it might not matter. Now, back to the body fat calculation. What our equation is it's equals, I'm going to put this in parentheses, 0.097 multiplied by the skin fold sum, close the parenthesis, plus, I think it's 3.64. And I'm going to click enter. Now, there are a lot of numbers in here, and that's okay for now. This is the equation for males. So this isn't enough, because we're giving females the male calculation. And although an equation doesn't exist, there are a couple of changes in these numbers that would give a more accurate representation of their body fat percentages, at least per college students' body fat percentage equations. So what I'm going to do is we're going to wrap this all around an if formula. We're going to say if the person's a male, do this, but if not, then do the other equation. So say equals if, open parenthesis, if the sex, and notice I clicked in the column or the row or I'm clicking on a cell that's in the same row as my equation. It doesn't matter which equation I do it in, it'll apply to all the cells in this column, in this table. But if I click on this cell, the one above the row that I'm in, notice it changes to G2. I don't want that. I want it to say at sex, so that it's referring to the sex of the person and not a specific cell. That's one of the big benefits of using tables. So I'm going to say if sex equals, quote, M, end quote, comma. So that's my logical test, comma. This is the value. This equation is the value if that is true, if sex is M. If it's not, however, comma, what I'm going to do is I'm just going to copy this and paste it next to it. And then I'm going to close a parenthesis. We didn't do anything new here. I'm going to click enter. So everything should stay the same. For the females, we're going to change this number here, the multiplier, to 1548 or 0.1548, and this here, the addition, to 3.58. And I'm going to click enter. Now we should see some numbers change. Now, to finish off my calculation like I did in the others, I think I did, if error, I'm going to go to the front and say, if error, open parenthesis, if there's an error with any of this stuff going on in here, this long complex equation, comma, I want it to be blank, which is 2 quotes. Close the parenthesis, click enter, and now I'm going to change this cell, because it's a calculation, to this red color. And what I'm also going to do is I'm just going to click on column Q because this body fat percent, it's not formatted the way that I want it to be formatted. So there are a couple ways that you could do this, depending on whether you want a percent sign or not. What I'm going to do is, well, the first thing that you could do is you could remove the number of decimals up here. Or, well, I guess first you would have to change this to a number, because it is a number. And we could say, you know, I don't want that decimal there, so I just want this. And that's fine. But what you could also do, if you want, is you could change the formatting to also display a percentage, even though it's not calculated as a percentage. And the way that you do that is you go to your number or your format of the text, whatever's in this column, go to more number formats, and you have a lot of options here. I'm going to go to custom. I think this is it. So I'm going to say I do want it to be 0.0. That's what it is right now, a number and a decimal. And this is Excel syntax, but I'm going to do a quote sign now and a percentage sign and another quote. Now what that is telling Excel is that I want this to be a number with a percentage sign after it. I'm going to click OK. Now that I've done that, my information is the same, it's just formatted a little bit differently. Now let's move on to our counter movement jump. Actually, before we do this, let's color all the cells that we need to red. So I clicked on one cell. I'm holding down the control key on a PC, clicking on broad jump best, Wingate relative peak power, ISO leg press average, ISO leg press percent difference, and just scrolling along, holding down control, clicking on all the ones that are calculations, and you can do this individually if you want. So I'm just selecting, oop, I don't want that one. If I click on it again, it'll remove it as I'm holding control. And I have all these selected. I'm going to change the color to red, and they should all become red. And I'm going to go back to the counter movement jump best. And I'm actually going to add in an average too, because I don't know if I want the best or the average, so might as well show you how to do both, which I think you can already do if you've used Excel. So I'm going to go CMJ average. Remember how we created the column? I just did it the same way that we did before. And to get the best, I want the maximum of these 3 trials. To do that, there's an equation called max. So I'm going to go equals max, open parenthesis, and it's asking me the numbers that I want the max of, just like we did for the, I don't know if we did that yet. All right, so, for the sum of the skin folds, which I actually need to color red. So I'm going to highlight these 3, and I'm going to close the parenthesis and click enter just to see if it works. Okay, so 22.5 is the maximum of these 3 numbers. 27.7 is the maximum of these 3 numbers. Now, I'm going to do if error, just like I've been doing. If there's an error with this, whatever's going on in here, comma, let's make it blank. Okay. So now that we have that done, we can do the average also. And maybe I can just copy this formula and be smart about it and paste it into the average. And all I have to do is change this max formula in here to an average. So I'm going to say average, and it might pop up for you, or it might not, depending on the PC and the version you have. And you can double click on it or just leave it as is. And I'm going to click enter. Now I have an average. Now, just notice that this formula is exactly the same as the max one with an average in there in case you didn't do it this way. I'm going to click on the column like I did before to format the numbers and go to number because I want them to be numbers, and I'm going to remove one decimal point just like the others. Now we can move along to the broad jump, and we have broad jump best. Maybe I just name that max instead of best because it makes more sense. So to get the maximum, we can pretty much do the same thing that we just did. And let's do it from scratch, but we could copy and paste the formula we did and change some things. But I'm going to go equals max, open parenthesis, select these two. You can do it, yeah, so you want to hold down the mouse. Oops, excuse me. It already did it, so I got the max, but you can do it a couple ways. So let's just make this blank. You can get equals max, and one thing that you can do is you can click on one, comma, click on the other, and that's fine. Close a parenthesis, and that'll also work. The way that I did it was a little bit different, where I selected the two, and you'll notice the difference is instead of a comma, you see this colon here. And this is good, but it can also be not good. So I'm going to close the parenthesis and click enter. Click on column X and add a new one. And you don't have to do this. I'm going to do this myself. If I type in a number 150 here, notice that this max calculation updates. You may want that or you might not. I'm going to undo what I did. Go back to this equation, and I'm going to do the commas. So I'm going to go to max, broad jump trial 1, comma, oops, broad jump trial 2, and close the parentheses. Click enter. Now, if I decide to add a column for whatever reason into my spreadsheet here that doesn't have to do with broad jump, let's call it sprint, I don't know, and I put in a number, I don't know, 1000, this number will not change. I prefer to do it this way. It takes a little bit more time, but I like it better for this reason, just in case. So I'm going to remove this column now. Go back into here and do my if error. So remember, we're using a comma. You can do it either way. Say if error, if there's an error with what's going on here, do comma, blank. Close the parenthesis and click enter. Now what I haven't done is with this one, for example, for the sum of the skin folds, I didn't do it that way. Remember this for the CMJ average and best, I didn't do that way. Maybe I should have. And what I'm going to do is, I might as well just do it now, but I was going to say I'd correct it in another video, but let's just do it. So I'm going to do comma. It's a little bit more difficult to read, but for the sum of skin folds, I'm going to click on the chest, comma, the tricep, comma, supra, and I'm just clicking a comma, and then the next one, comma, then the next one, comma, then the next one, comma. And I just noticed actually, I'm going to click enter, after I selected everything that I want, that I don't have an if error around this, and I want there to be one. So if there's an error with this formula, comma, I want it to be blank. Okay, so we still have the same results, and I'm going to do the same thing with the best and the average, where instead of doing it this way, do a little bit quicker now, but you should be able to figure it out. comma, trial 2, comma, trial 3, close the parenthesis, comma, blank. Not sure why that's happening. Let me try that again. Oops. All right, I guess I'm just going to do it from scratch. So equals max 1, comma, 2, comma, 3, close a parenthesis. If there's an error, let's make it comma blank. And same thing with the average. Let's just copy the max formula over again because now it's different. And let's change the max to an average. And click enter. Now let's continue on here. We're not almost done, but that's okay. You might not have as many equations as me, and you may not have percent differences or averages or maxes or things per body weight. This is Wingate relative peak power, but if you don't, you can just pretty much skip through this entire video. So to calculate Wingate relative peak power, we're going to divide the Wingate peak power by the person's body weight. So to do that, their body weight's in pounds, first of all. So if we want watts, this is in watts, I should actually add that. If we want watts per kilogram, that would be a different equation than if we want watts per pound. And I think watts per kilogram is more traditionally used. So with their body weight being in pounds, we're going to have to make this formula a little bit more complex than it needs to be. An alternative is to add a column and calculate the body weight in kilograms. But we want to try to limit the number of columns we have in this table. It's already pretty long. So to do this, we go equals Wingate peak power divided by, and I'm going to open a parenthesis, body weight divided by 2.2, and close the parenthesis, and I'll click enter. And now what we have in here is watts per kg, and maybe I should have done this better. Maybe this is W per kg, and broad jumps are in inches. CMJs are also in inches. I should have been clear about this to begin with. It's a fault on my part. Sometimes I don't write that in there because it just makes the equations longer. So the more information that you have in a cell or in a header, the longer the equation is. You see the W in parentheses here in this equation. But now I need to do the if error. So if there's an error with this formula that gets me the watts per kg, do comma blank. Click enter. And again, I'm going to do the same formatting that I did before where I click on the column and I'm going to go to number and remove one of those decimal places up here. All right. Now I have ISO leg press average. I actually don't know what this is in, but I'll keep that for now. And what I'm going to do, remember these are peak force values. So I'm going to get the average between these two things, and we're going to use the comma strategy. Equals average, open parenthesis, this one, comma, and this one, close the parenthesis, and click enter. It looks like it works. I'm going to say if there's an error, if error with this average, comma, blank, click enter. And I'm going to do the same thing that I did before where I just reformat it, where maybe I want this to be a number, but I just want it to be a whole number because I don't really care. The number's so big that the 0.5s don't matter to me. Now, percent difference. Now, there are a couple different ways that you can do this. The way that I'm going to do it is I'm going to do pretty much right over left. So the calculation looks like, at least the one that I'm going to use, and like I said, there are a lot of different ways to do it, is I'm going to do equals the value from the right, and I'm going to put this in a parenthesis up here, minus the value from the left, close the parenthesis, over, divided by the value from the right. I don't know which limb is dominant in each of these people, so that's kind of my rationale for doing it this way. Say, at the beginning, if there's an error, oops, I messed up the equal sign. So equals, if there's an error with anything going on here, let's go comma blank, and I'll close a parenthesis. Now this isn't formatted the same way that the body fat percentage is, at least in our calculation. We could make it that way. For example, if we divided the body fat percentage by 100, but what we're going to do here is we want this formatted as a percentage. Right now it's a decimal. I can click again, go to percentage, and maybe I want to reduce the number of decimals here. And in this instance, what we have here is negative values indicate that the right is weaker or did not perform as well, where positive values infer the inverse. And we need to know that when we use our calculations. So as we move forward here, I may actually decide to invert this at some point, just because when I'm thinking from a graphical perspective, if we want a bar going to the right or the left, right is generally more positive. Yeah, I'm just going to do this right now, actually. So if there's an error, or sorry, we're going to wrap this in parentheses, the equation that is, and then go times minus 1. We could have just done it the other way, but I'm lazy. So now what we see, click enter, this is the equation. We have the right. If the right is weaker, wait, no, I didn't want that to happen. Here, actually, let me undo that. All right, I'm back to the original, and I'll think about this later because I need to give it more thought. Now let's go to the Wingate relative mean power, and we already did a calculation like this with the Wingate relative peak power. So I copy this formula and paste it here. We get the same thing as the peak power, but instead of the peak power, that we divide by body weight, we want to divide. Maybe I should delete this whole area. We want to divide the Wingate mean power by body weight, or kilograms of body weight. Click enter. So now this is the mean power relative to the person's body weight in kilograms. We're going to keep on chugging along here. The first thing that we see for Y balance is composite score. And we've already done sums and things like that, and that's essentially what we're doing here. For the left, I'm going to equal sum. And in this case, let me just be clear, highlighting them all won't work. Well, it will if you move your columns around, but right now, our left values come before our rights. And if we were to highlight cells, it would include the right values. New equals sum, open parenthesis, anterior, comma, posterior-medial, comma, posterior-lateral. And close that off, click enter, and I'm going to do the if error, comma, if there's an error with whatever's going on here, comma, let's make it blank. And I'm going to do the same thing here for the right, equals sum, open parenthesis, anterior, comma, posterior-medial. And again, we see that popping up here as we go through the equation. That's how we know we're doing it right. And posterior-lateral, close the parenthesis, click enter, and we will do, if there's an error, with this, make it blank. And now we're going to do the same equation that we did before for pretty much for the isometric leg press percent difference. And this is the most important part, is that whatever asymmetry equation you're using, or symmetry equation, it's consistent with all your metrics. So we're going to use the same one. It's right minus left over right. And if we decide to make a change, we'll do it holistically. So we're going to go equals anterior right minus anterior left and let's put this in parentheses, divided by anterior right. And I'm going to say if there's an error with anything going on in here, comma, let's make it blank. Click enter. And you can do the same thing. Maybe I copy and paste this. That's probably the fastest way. I'm going to go through it a little bit faster now, where I copy, paste it, change anterior to P medial, and it pops up. Change anterior to P medial, and it pops up. Change anterior to P medial, and it pops up. What I just noticed here, and you can see this is actually a pretty cool feature if you're on a PC, I just see one cell selected here. And that's because I refer to the posterior medial right leg all 3 times. I actually want this one to be left. And now we can see that our equation in the red includes these 2 cells. It's a pretty nice feature if you're on a PC. I'm not sure if Macs have it. Click enter. And I'm going to do copy and paste and do the same thing with P lateral right minus P lateral left over P lateral right. Click enter. And the final one is composite, which we already calculated here. Copy and paste and change this again to composite right to composite left to composite right. And if you don't want to do this copy and paste job, you can do it the exact same way that we did the first one, where we type it out manually. You can do that for every one. Click enter. I'm going to click on AV, hold down shift, click on AY, and we're going to format this, all these, because they all require the same formatting to be interpreted in the way that we want, is percentage. And since everything's selected, if I reduce the decimals, it'll be applied to all of them. And we're going to keep on trucking along here. We're almost done. And as we get to the sport-specific section, I mean, usually we're probably going to have multiple trials of some of these things. And I intentionally it's too much. You guys get it. If you do have multiple trials and you want a minimum or a maximum, you'll know how to do that through this. So for the on-ice test, which is a conditioning test where they perform 6 bouts, we want to get the average time as a measure of conditioning equals average, open parenthesis, and I'm going to do the comma method that I did before. Trial 1, trial 2, trial 3, trial 4, comma, trial 5, comma, trial 6. Close the parenthesis and click enter. And then same as I did with the others, do if there's an error with any of that, comma, blank. And what we might get here, I'll discuss in a second. And I'm going to make this a number. This is a time. And now I'm going to copy this formula and paste it to these 2. Copy and paste. I want the minimum time, where I'm going to change average to MIN. Should still work, and click enter. Now this is their fastest time. I can copy this formula and paste it to maximum and change the min to MAX. Click enter. So now we have a minimum time and a maximum time. Now we have a percent drop. You may not care about this. There are a lot of different ways to calculate this. You could do their first one, like how much was the drop off between their first and their last, or what was the drop off between their max and their min. Let's just use the max and the min if this is something that's important. You may want to even identify where the slope is the greatest between drop off if it's a semi-linear relationship or non-linear relationship. So I'm going to do equals to get the percentage of drop, open parentheses, maximum minus minimum, close the parenthesis, divided by maximum. And I'm going to go to the front and say if there's an error, open parenthesis, comma, let's make that blank. Click enter. Again, this is a percentage. I'm going to click on BL, go to percentage, and remove a decimal. Now, I want to hit on something here, or actually a couple things. The first is that I'm going to scroll down. Notice that there are things going on here that we may or may not want, and we can address these later, but essentially what's happening here is we don't perform, and this is typical, I think, this is why I did it this way, is that there are tests as I scroll across here that aren't performed in season. A lot of tests are, but I chose to remove a couple so that we could play around with what's presented and how it's presented. For example, there's no on-ice conditioning, and there's no VO2 max assessment in the season during these in-season testing sessions. We see starting here. Now, you may do every test in every session, and that's fine, and you could do it that way. In my experiences, that hasn't been the case, and honestly, there are probably a lot less tests than this that are done in the season. You may just do one or two of them. Maybe it's just counter movement jump, or maybe it's just a wing gate, or maybe it's just trap bar. I don't know. So that's the first thing. The second thing is, in this example, I have calculations after input systematically throughout this table. What I generally do is I have nearly all my calculations at the end. And the reason why I do that is for copying and pasting if I need to. Right now, if I were to copy the information in this table, it would get a little bit convoluted. If I tried to paste it, I'd have to do it in separate events because there are calculations separating everything. But I guess that's neither here nor there. And the last thing that I want to mention is that this on-ice test, and you may be interested in this, is every trial is performed in an opposite direction. So we go to the left first, then the right, then the left, then the right, etc. You could, if you wanted to, if you have a test like this where there are repeated bouts going different directions, calculate an asymmetry if you want for that test because you're going different directions. And then to do that, you would take the values or the average values of the left trials, which might be the first, third, and the fifth, and you would perform a similar calculation that we did versus the right trials, which might be the second, fourth, and sixth. So I hope this video was helpful, and in the next one we're going to talk about how to plan, or we're going to plan out what we want our dashboard to not look like, but how we want to interact with it. And that's an absolutely crucial step before you start actually doing calculations in the dashboard. And we'll also probably go through the reference sheet a little bit and add some things that are important for our interactions. I hope you enjoyed this video, and I'll see you in the next one.